The BGM-71 TOW anti-tank missile system entered service with the U.S. Army in 1970 and has since become one of the most widely deployed anti-armor systems in the world. The weapon has seen extensive combat use across multiple conflicts and remains in active service with numerous operators, including Ukraine. Most weapon systems eventually reach the end of their operational lives as newer and more capable technologies enter service. The TOW, however, has defied that trend. This longevity is reflected in the latest U.S. procurement decision. Raytheon, part of RTX, has received an additional $536 million contract modification for full-rate production and related services for the TOW system. The latest award brings the total value of the agreement to approximately $750.8 million. The work will be performed at Raytheon's facilities in Tucson, Arizona, and is expected to be completed by approximately August 31st, 2027. The customer is the U.S. Army Contracting Command at Redstone Arsenal, Alabama. A system that is more than 5 decades old is still getting contracts shows exceptional resilience. Let's dissect this. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. The BGM-71 TOW, tube-launched, optically tracked, wire-guided, is one of the most extensively developed anti-tank guided missile ATGM systems in service. Originally entering U.S. Army service in 1970, the system has undergone multiple generations of upgrades to its guidance, propulsion, warhead, and countermeasure resistance. A defining characteristic of the TOW is its command-to-line-of-sight (CLOS) guidance system. After launch, the operator keeps the missile aligned with the target using the launcher's optical tracking system. Guidance commands are transmitted to the missile through a command link. This arrangement gives the weapon a relatively simple engagement concept. Once the target is acquired, the gunner maintains the sight on the target until impact. Unlike a fire-and-forget missile, however, the operator must continue tracking the target throughout the engagement. The original BGM-71A had a maximum range of approximately 3,000 meters, while subsequent TOW variants generally increased this to 3,750 meters. This extended engagement envelope allows TOW teams to attack armored vehicles from considerably greater distances than conventional direct-fire anti-armor weapons. The U.S. Army has also described later TOW variants as capable of engaging targets at ranges approaching 2.5 miles, 4 kilometers. The missile's lethality has evolved substantially. Early TOW versions used a conventional shape charge warhead, but the improved TOW, TOW, introduced an extending probe that increased the distance between the shape charge and the target armor. This is important because a shape charge warhead requires an appropriate standoff distance to form an effective penetrator. The later TOW 2 incorporated a larger full-caliber warhead and increased propulsion performance. The TOW 2A represented another major increase in anti-armor capability. It introduced a tandem warhead configuration, specifically intended to counter explosive reactive armor, ERA. The forward charge initiates the ERA or otherwise clears the protective layer, allowing the primary shape charge to attack the underlying armor. This represented a significant adaptation to the increasing use of add-on and reactive protection on armored vehicles. One of the most technically distinctive versions is the TOW 2B. Rather than relying solely on a direct impact against the vehicle's frontal or side armor, it uses a fly-over top attack mechanism. The missile passes above the target and employs explosively formed penetrator, EFP, warheads directed downward against the vehicle's upper surfaces. This approach exploits the fundamental vulnerability of armored vehicles. Roof protection is generally lighter than frontal armor. The TOW's most significant technical limitation is its command guidance architecture. During an engagement, The gunner must continuously maintain the sight on the target while the launcher's fire control system tracks the missile and transmits guidance commands. Because the missile relies on the launcher's guidance system, it does not require its own sophisticated terminal seeker. The trade-off, however, is significant. The operator must remain exposed and committed to the engagement until the missile reaches the target. The FGM-148 Javelin, which entered U.S. Army service in 1996, takes a fundamentally different approach. Its missile incorporates a passive imaging infrared seeker, allowing the operator to acquire and lock on to the target before launch. Once fired, the missile guides itself autonomously, enabling the operator to immediately relocate or seek cover. On a modern battlefield, this fire-and-forget capability gives Javelin a significant survivability advantage. An operator using Javelin does not need to remain exposed throughout the missile's flight, reducing the risk of detection and counterfire, particularly important when engaging armored vehicles equipped with advanced electro-optical sensors and rapid response weapons. However, TOW retains one major advantage that is difficult to overlook: cost. A modern TOW variant, such as the TOW 2B Arrow, has historically cost around $100,000 per missile, while Javelin procurement costs have generally been substantially higher, with some recent U.S. procurement figures approaching $300,000 or more per missile, depending on the contract and what costs are included. In simple terms, a force could potentially procure several TOW missiles for the cost of a single Javelin. That price differential becomes particularly significant in a prolonged high-intensity conflict, where anti-tank missiles may be expended in large numbers. Despite its age, the TOW remains relevant as a relatively low-cost anti-tank missile capable of engaging targets at ranges of up to approximately 2.8 miles, 4.5 kilometers, depending on the variant, while delivering substantial destructive power through its evolving warhead configurations. There are indications that the system can pose a threat even to some of the most modern and heavily protected armored vehicles. In 2020, according to the Russian media outlet Reporter, Russian T-14 Armata tanks reportedly took part in fighting against Syrian rebels in Latakia province, where, allegedly, 3 T-14 tanks were hit from TOW 2B anti-tank system, and one Armata was completely destroyed. The credibility and precise circumstances surrounding these reports remain difficult to independently verify, but since it comes from a Russian outlet, it is hard to ignore. The TOW's extensive integration across U.S. and allied armored platforms is another factor supporting continued procurement. The system has been integrated with platforms such as the M2 Bradley Infantry Fighting Vehicle and other vehicle-mounted launchers, providing forces with an established anti-armor capability without requiring an entirely new weapons architecture. Given its relatively low cost, long engagement range, evolving warhead technology, and extensive platform integration, continued procurement of TOW missiles therefore represents a pragmatic approach. Rather than replacing the system solely because of its age, the United States can continue exploiting an established architecture that has repeatedly demonstrated its ability to adapt to changing battlefield requirements.